universe itself was created in an enormous explosion some 13.7 billion years ago. Right there in that first instant, time began. And space? Well, there was so much pure energy all of a sudden that space itself couldn't stand it. So from just about nothing, space zoomed faster than thought to an enormous size. Good thing too, because gravity was about to squeeze that baby universe back into the nothingness it came from. That first zoom happened a whole lot faster than the speed of light and is called inflation. Since then, the universe has expanded at more of a pedestrian speed of light. At the incredible temperatures and energies of that first instant, nothing, not even matter, was stable. And as quick as it could form, it turned back into pure energy. But as the universe expanded, it cooled. And gradually the basic pieces of normal matter were formed from that incredible energy. Quarks were the first particles to form. Today, quarks only exist in tightly bound groups. But back then, space was so small and quarks were squeezed so close together that they were not bound to other specific quarks. The colors of these quarks just represent a property that attracts them to one another. There are two kinds of quarks in normal matter. Physicists call them flavors of quarks. There's the up quark and the down quark. As space got bigger, quarks lost their freedom and found themselves locked into groups of 3 inside a proton or a neutron. Just about every proton and every neutron in existence today was formed at the time of inflation and was crammed into that primordial basketball. At this point, every neutron was in a desperate race for its life. Since neutrons can only exist for about 20 minutes on their own, every neutron either decayed or got together with a proton to form a kind of hydrogen. Or 2 neutrons got together with 2 protons to form the nucleus of helium. All of this happened within the very first minute of existence of the baby universe. Electrons were the final basic particles to freeze out of the energy soup. But the energy density was still way too high for electrons to join together with other particles. And the early universe remained a glowing, cloudy plasma. This condition lasted about 300,000 years while the universe grew and cooled. Finally, it was cool enough for the electrons to be captured by hydrogen and helium nuclei, and the first atoms were formed. Suddenly, light could race through the universe without bumping into charged particles, and the universe became transparent and dark, filled mostly with clouds of hydrogen and helium gas. The light released at that time is still visible today as cosmic microwave background. So how did an almost perfectly dark and smooth universe become littered with stars? Inflation itself caused the first tiny ripples in the density of matter. And over a period of about 10 million years, matter increasingly gathered at these denser locations. After 100 million years, the center of each cloud evolved into a star as massive as 100 suns. Across the universe, these first-generation stars lit their furnaces as their cores became hot and dense enough for nuclear fusion. The universe emerged from the Dark Ages. Because of their huge sizes, these first stars burned with a frenzy and converted their supplies of hydrogen and helium fuel into the first heavy elements. Essentially, all the atoms in the universe heavier than helium were born in the hearts of stars. In a short 3 million years, the fuel was spent, and these first stars collapsed and exploded into supernovas. spewing their newborn heavy elements out into the universe. This new composition of heavier elements made it a lot easier for gravity to squeeze these clouds of matter into new generations of stars.